So in this lecture, we will introduce gears kinematics. We have already introduced in the previous chapter, whenever we have two gears in mesh, the gear ratio is defined as omega out over omega in, which is the ratio of angular velocities of the driven over driver gear. And we have seen that it can be correlated to the ratio of radii, and it's inversely proportional to the ratio of radii because we have same velocity, linear velocity at the contact point. And of course, we can have a positive ratio or a negative ratio, depending on the set. So if we just have two gears, an external set will lead to opposing angular velocities, while if we have just two gears in internal set, then we'll have a same direction for angular velocities. Now, in this chapter, we'll see trains of gears. So, and we see how to design a train of gear in order for a certain application. Sometimes we want to reduce the velocity, and this will require then increasing the torque, as we'll see together. So this is called lower gears. If our purpose is to increase the angular velocities, then we'll decrease the torque, and this is the case of higher gears. And concerning the sets, we can talk about two types of sets, external and internal. An external set, when just we have two, for each two gears in contact in an external set, we have reverse direction. Now for internal sets, we have rotation in same direction. Again, if I'm just considering two gears, but we'll see together that you can have, for example, three gears in external set. So if the number of gears in external set is an odd number, then the input angular velocity will be the same as the output angular velocity. Because if we say this is one, let's say 1, 2, 3, 1 and 2 will have opposite angular velocities, and 2 and 3 also will have opposite angular velocity. So in total, 1 and 3 will have same direction for the angular velocity. So we say that whenever we have external set of gears, if the number of gears we have is odd, then we have same angular velocity rotation, same direction. If we have it, if we have a number of gears even, then it will be opposite directions. Now, let us go back to the fundamental laws of gearing. If you consider just two gears in contact, we name the smallest one as pinions, the largest one as gear, and we have some constraints due to the meshing of these gears. The first constraint is common linear velocity. Because of the common, and here, for example, in this case, the linear velocity will be in this direction because the pinion is rotating counterclockwise. So from the right-hand rule, you have the velocity towards the right. And for the gear, because of you have same velocity, then omega should be clockwise. So it should be opposite to omega of pinion to have same direction for the linear velocity. Now, concerning forces, we talked already about forces. We said that by action reaction, here's the driving gear is the pinion. So it will act, it will do a force on the gear in this direction. This force will be driving the gear. However, for the pinion, the action of the gear on it will be opposite and it will oppose its rotation. This is why when we have a driver gear, we should put a certain, let's say, for the main driving gears, you have a couple M that is transmitted through a motor. This couple will create, if you want, the rotational effect. So here the couple will be in the counterclockwise direction. The force of the gear on the pinion will be trying to oppose this, so it will create a resistance to motion. However, the transmitted force to the gear will have the role of a driving effect. So this is here the driver, this is the driven gear. And we can say that the magnitude of the force is the same by action reaction. And we know that whenever we want to talk about torque, we can write that the torque is force times radius, okay? So the torque produced by the transmitted force is equal to T over R. And since the force is equal, so just here we should fix it. It's T out over R out equals to Tn over Rn, because same transmitted force and magnitude. And then we can deduce that the ratio of radii is equal to the ratio of torques, okay? Because if you take Tn to this side and R out to the other side, you get that Tn over T out is equal to a ratio of Rn over R out. Now, concerning also, this is if we talk about magnitudes. If we talk about directions, as we can see, these torques have opposite direction, because the forces, as we said, are opposite. So the force transmitted by the pinion on the gear will create a torque in this direction. However, the by action reaction here, the force is, if you want, you have an opposite force. So the torque here, if you want, when we talk about the total torque, T in, T out, it will be the same ratio as the angular velocities and opposing the value of Rn over R out. Okay, so you have that in total. For the torque ratio, you can say that Tn over T out is inversely proportional to omega out over omega n. Why? Because the power transmitted is the same. So you have the same value of power transmitted. So you have same value of power. So we can say that Tn omega n should be equal to T out omega out. We know that the product of power is torque times angular velocity. And since we have same power, it's a transmitted power, we assume no losses, then Tn is equal to T out W out. And then we can relate also the ratio of torques to the ratio of angular velocities. The ratio of torques is inversely proportional to the ratio of angular velocity. So it's proportional to the ratio of radii, of pitch radii, of course, and to the ratio of pitch diameters. Now, let us use this to do the analysis of gear trains. So if we look at the following figure, for example, you have a set of gears in mesh. So this is a simple gear train. When we say simple gear train, this means that each gear is attached to one shaft. So you have one gear per shaft. And in such gear trains, we'll develop together a general relation for the gear ratio. So when we have collection of two or more meshing gears. So first, let us consider in this example, what is the gear ratio? The gear ratio is defined as omega out over omega n. And then if we look at our figure, omega out here is omega of gear 6, and omega n is supplied for at gear number 2. Now, why we start counting from 2? Because here we consider that we are counting links, and the ground constitute link number 1. Okay, so we have 1, 2, 3, 4, 5, 6, and then we have 5 gears, okay, in contact within each other. Now, in order to develop a general relation for MV, let us first decompose it. We need to find the ratio omega 6 over omega 2. So let us divide it into parts, because as you can see, gear 6 is in direct mesh with gear 5. So we can find the ratio omega 6 over omega 5 as inversely proportional to the number of teeth. And here we provide you with the number of teeth of each of our gears. So we need to link the ratio of angular velocities to the ratio of number of teeth. We already know that the ratio of angular velocities is inversely proportional to the ratio of number of teeth, because the number of teeth is proportional to the diameter or radius of pitch radius or pitch diameter of your gears. So I will start by saying that I will decompose omega 6 over omega 2. I will first write that it's equal to the ratio of omega 6 over omega 5 times 5 is in mesh with 4. So I have omega 5 over omega 4. 4 is in mesh with 3. So I can multiply by omega 4 over omega 3. 3 is in mesh with 2, so I can multiply now by omega 3 over omega 2. Okay, so as we can see, we can decompose the gear ratio of the total system to gear ratios for each set, for each 2 gears in mesh. Okay, and then we can relate the ratio of angular velocities to the ratio of number of T's. You know that omega 6 over omega 5 is inversely proportional to the ratio of number of T's between 5 and 6. And because whenever you have 2 gears that are set as external to each other, then you have a negative ratio. So it's minus n 5 over n6. And you can replace omega 5 over omega 4 by minus n4 over n5. Similarly, you can do it for this. So this is minus n3 over n4. And finally, for the last one, it's minus n2 over n3. Sorry, n3 over, no, 1 second, 5, 4, 3. Yeah, here it's 3 over 2, okay? 3 over 2, so here it's n2 over n3. Okay, so now, as you can see, I can replace mv by the following, which is for each gear set the ratio of number of T's. And you can deduce that I can simplify the intermediate gears. So the number of T's will cancel out. And I will have here in total minus 1 to the power 4 times n2 over n6. So what is the general conclusion I can take? First, to know if the angular velocities are same direction or not, I should check the number of gears. Here, when I have 5 gears, so I have like 4 sets, okay? I will have, in this case, minus 1 to the power. So in general, I get minus 1 to the power n minus 1. N is the number of gears here. Here I have 5 gears, so it's 5 minus 1. So minus 1 to the power 4, which will give me a positive ratio. So here mv is positive, and it's equal to the number of T's of the driving gear over number of T's of the driven gear. So the general rule is the following: whenever I have a simple gear train, so whenever I have several gears and I have 1 gear per shaft, I can say that mv, which is the ratio, is equal to minus 1 to the power n minus 1, where n represents the number of gears. This is why we'll see that when n is even, okay, then you will get a opposing angular velocities. So mv will be negative. However, when n is odd, like here, you have 5 gears, your ratio will be positive. So this is number of gears, and it's equal to minus 1 times n minus 1 times number of T's of driving gear over number of T's of driven gear. So you just look at the final initial and final gear if you want. Okay, now why we use such trades? Because it's not recommended, okay, for just 2 gears to have a velocity ratio larger than 10/1. So because this, if you have a ratio larger than 10/1, the dimensions, you know that the velocity ratio is inversely proportional to the radii ratio or diameter ratio. So if you have a very large ratio, you need to have very different dimensions between your pinion and your gear. And this is not recommended. First, we have seen, for example, that this can cause interference. Okay, so if you have a large difference between pinion and gears, this can cause interference between the two. This is why we limit ourselves in the design. Whenever we have 2 gears in contact, these 2 gears should not have a velocity ratio larger than 10 or smaller than 1/10. And here it's equivalent. It depends if the pinion is a driver or the gear is a driver. So the velocity ratio should not be larger than 10/1 or smaller than 1/10. Okay, and then this will impose certain constraint on the design. This will tell you how many gears you need to achieve a certain velocity ratio. Okay, any question on this? Now,
دكتور ما كثير فهمت الفيلوسيتي ريشيو.
الفيلوسيتي ratio, okay. يعني أنا مثلا if I tell you I want to design a system of gears in a way إنه omega output over omega input يكون equal to 20. Okay. Then فيك تقول لي بستعمل بس 2 gears. يعني أنا إذا بعطيك gear of radius example يعني يمكن مش موجود بدك تشوف السايز إذا موجود أو لا. If I give you a gear of let's say of dimension أو إذا حنحكي number of teeth إذا بدك. إذا البنيون عنده let's say 10 teeth. أوكي. مفروض الجير تيطلع لي ratio 20. أوكي. مفروض الجير يكون 200. النمبر اوف تيس تبعه. شفت قد ايه في ديفرنس؟ يعني هون بده يكون اذا بدك اذا عم نحكي انه مثلا الجير هو الدرايفنج والبنيون هو الدريفن، ساعتها اوميجا اوت اوفر اوميجا ان بتكون equal to the number of teeth على الانبوت اللي هو الجير over the number of teeth على الاوتبوت اللي هو البنيون هون، فبيطلع 200 over 10 بيطلع 20. هلا اوكي you can reach it with 2 gears بس عندك مشكله. اول شيء you have احتمال كبير يكون في interference و you have very difference in dimension between your pinion and your gears. This is not desired. Okay, in general it's better to have pinion and gear انه هنا اكيد الجير اكبر بس ما يكون في large difference between the two. ف if you want to create a similar ratio but without this difference in dimensions فيك تقول انه انا حقسم ل several sets بدل ما set واحد يعطيني ratio of 20 مثلا 20 كيف فيني اقسمها؟ اذا بعملها if I divide 20 in multiple numbers يعني اول شيء بقسمها على 2 بتعطيني 10 يعني برجع بقسمها على 2 بتعطيني 5. So 20 can be decomposed into 2 times 2 times 5. اوكي يعني فيني مثلا اخلق اذا بدك هون عندي 2 possibilities او بستعمل مثلا 3 sets يعني اول set بيكون الريشيو تبعه 2 ثاني set 2 وثالث set 2. اذا انا بدي 3 sets اوكي مفروض يكون عندي النمبر اذا بدك of gears هو like this يعني عندي هيدا أول set هيدا مع هيدا first set هيدا مع تاني set 2 وبعد بدي واحد بيطلع لي 3 sets. okay يعني for one set you need 2 gears. One set you need 2 gears. If you have 2 sets بدك 3 gears etc. 3 sets 4 gears. هون مثلا عندنا 5 gears يعني عندنا 4 sets لحن 1 2 3 and 4. okay now إذا أنت بدك to smooth the transition of velocity مش فجأة يعني يكون في big difference بين البنيون والجير بدك تزيد النمبر of sets يعني to create 20 a ratio of 20 أو بدك تستعمل 1 set هو يكون ratio تبعه 20 فيك تستعمل 2 sets واحد منهم 4 يعني 2 times 2 بتعطيك 4 وتاني set 5 الريشيو، وكمان فيك تستعمل 3 sets، واحد 2 التاني 2 الريشيو تبعه والتالت 5. اوكي so you can do several design تيوصل لك نفس الريشيو، بس اكيد كل ما كان النمبر اوف جيرز اكبر كل ما الترانزيشن is smoother وكل ما you reduce the possibility of interference. okay this is why we recommend انه we should select sets قد ما فينا يكونوا اذا بدك كل ما كتروا كل ما احسن، وكل ما كمان نقيناهم بطريقه يكونوا النمبر اوف اذا بدك يعني الريشيو تبعهم قراب على بعض بيكون احسن. يعني مثلا اذا بدي 2 sets فيني اخذ 2 times 2 4 مع 5، وفيني اخذ 2 مع 5 10، بصير عندي set عنده 2 set عنده 10. اكيد you prefer 4 و 5 لانه 4 and 5 are closer to each other، وبتكون صغرت بدل ما تكون عندك واحد 10 واحد 2، ال 10 is critical يعني you should not exceed 10. So of course you will, if you have 2 sets you prefer to use for one set a ratio of 4 and for the other set a ratio of 5. Okay وضحت شوي الايديا؟
Yes, Doctor. Thank you.
Okay. Now what if we have okay, just some rules على simple gear trains. So as we said, if you have an odd number, the output will have same direction as input. If we have an even number, the output will be opposite to input, and the effects of all internal gears will cancel out. لأنه we have seen إنه the total ratio depend on the number of teeth على على input over the number of teeth على output. Okay. And intermediate gears are called idlers. So now let us see more complex trains. Okay, in the simple gear trains you have one gear per shaft. However, when we talk about compound gear trains, we can have more than one gear per shaft, and in this case, at least in compound gear trains, at least one shaft will carry more than one gear. And in this case, we have parallel or series parallel arrangement. So you have, as you can see here, you have, for example, for this shaft, you have 2 gears connected to the shaft. So whenever you have one shaft carrying more than one gear, this is a compound gear trains. And this will allow you to reach larger ratios than 10/1 in a simple way. And we'll derive together how we can make a general rule to find the gear ratio in a simple way for such gear train system. So first, if we look, this is 2 views of the gear train system. You have the profile view, so view from profile, and view from top. So if you look from top, so this is top view, and this is profile view. And therefore, you can see here that I can relate the angular velocity at output to input through the following relation. Let us derive it together. So I need to get MV, the gear ratio. The gear ratio is omega out over omega n. I can start first. What is my output? My output is gear 5. هلا first how I name my gears. As usual, the ground قلنا هو link 1 always. So this is number 2. This is number 3. This is 4. And this is 5. So in total here, I have 4 gears. Okay, 4 gears. 2 of them are driving gears and 2 are driven gears. Let us see how. First, your main input هو 2. يعني you will provide a torque on 2. Okay. So let's say we have imposed torque here. You have rotation of 2. The rotation 2 is in mesh with 3. So 2 will drive 3. So we can consider that 2 is a driver and 3 is a driven gear. Now, Since 3 and 4 are connected to the same shaft, okay, then they will have same angular velocity. 3 and 4, because connected to same shaft, will have same angular velocity. And then the motion imparted from 3 to 4 will be driving gear 5. This is why we say that 4 is a driver and 5 is a driven gear. Okay, so in total here you have 2 driver gears and 2 driven gears. The driver ones are 2 and 4, and the driven are 3 and 5. Now, let us try to get the gear ratio for this system. So MV is equal to omega 5 over omega 2. So as usual, I can decompose it into parts. So I say, I look, 5 is in mesh with 4. So omega 5 over omega 4. Then 4 is in mesh with 3. So times omega 4 over omega 3. 3 and 4 are equal. If I do times, if you want, هيدي omega 3 omega 4 مش in mesh, they are on the same shaft, same angular velocity. So I can replace 4 and omega 4 over omega 3 by 1. Okay, because they are on the same shaft, so they will have same angular velocity. Now 3 is in mesh with 2. Okay, so it's times omega 3 over omega 2. So this one will cancel out because it's already 1. Now we can replace omega 5 over omega 4 by the inverse of number of teeth ratio with a minus, because any two external gears in mesh will have opposite angular velocities. So MV will be equal to minus N4 over N5 times minus times 1, بس ال1 انه فينا ما نحطها, times minus N2 over N3. And then you can conclude the following. First, how many sets you have here in total? You have 2 sets. 2 and 3 constitute 1 set. Okay, so this is set 1. And 4 and 5 constitute a second set. So this is set number 2. So in general, MV is equal to minus 1 to the power n, which is the number of sets. Okay, here we have 2 sets. This is why, because we have 2 sets here, the angular velocity of the output and the input are along same direction. Okay, so we have here 2 sets, and we have that we have times N2 times N4 over N3 times N5. So you have here in total نعم
دكتور 3 و 4 ما بنعتبرهم سات؟
لا ما بنعتبرهم سات، لانه اصلا هن على same shaft. اوكي، وعندهم same angular velocity. يعني انت in total هون كم عندك جير؟ عندك 4 gears. مزبوط. هول الفور 2 منهم درايفر، 2 منهم دريفن، يعني عندك 2 sets. اوكي، هون اذا بدك طريقه عد السيتس بالكومباوند جير ترينز مش هي ذاتها كيف بنعد السيتس بالسمبل جير ترينز. اوكي so here you have اذا بدك النمبر of sets بالكومباوند جير ترينز بيكون equal to the number of driver gears او number of driven، هي ذاتها. اوكي، so اكيد اذا عم نحكي انه في two يعني الانترميديت shafts في عليهم بس 2 gears. هلا we can have more complex scenarios. هلا we'll see them after. Okay, so in this case at the end you will get the following. You will get the general rule here انه -1 to the power the number of sets. يعني اذا number of sets is even بيطلع لي positive ratio. اذا number of sets is odd بيطلع لي negative ratio. والratio حيكون equal to the product of teeth on driver gears over product of teeth on driven gears. Okay, so this is how I can determine in a fast way. يعني هون بدل ما كل مرة أعمل decomposition دغري بتطلع how many driving gears I have 1 2 how many driven 1 2 يعني لأنه عندي 2 sets إذا بدكم حيطلع positive الراتيو وحيكون equal. شو هن قلنا driver gears هن 2 4 يعني بحط على النيميريتور and 2 times and 4 وعلى الدينوميناتور and 3 times and 5. And in this way, I get my ratio. Okay. Now, let us see. Here are the details of the derivation اللي عملناها أنا وياكم. So this is how we decompose the ratio, and then we get the general rule. We can extrapolate the general rule from this demonstration, and you can see here the top view والprofile view of the system. فيكم تشوفوا انه الانترميديت شافت هو عليه 2 gears وعندنا الانبوت شافت في عليه بس الانبوت جير المين انبوت جير والاوتبوت شافت في عليه المين اوتبوت جير. Okay, now let us do a sample, an example on how to design compound gear trains. Okay, so when we do the example, you'll understand better the procedure. So let us design a compound gear train for an exact velocity ratio of 180 over 1. Find a combination of gears which will give you this ratio. فإذا نحن we need to produce this ratio. Okay, to produce this ratio مفروض يكون عندنا omega out over omega in equal to 180. فينا نستعمل one set بس it's very bad. يعني it's much larger than 10. يعني أكيد one set مش حيمشي الحال. Okay, so بنبلش نقول إنه already حننطلق minimum من أصلاً تنحكي ب compound gear trains ما في يكون عندنا one set. يعني we have several sets. We can start with 2 sets. يعني the minimum possible number of sets is 2. Let us say we are using 2 identical sets. وقت يكونوا identical يعني اثنيناتهم عندهم same gear ratio. Okay, يعني مثل ما شفنا فوق إذا بناخد بس 2 sets شو حيكون ال MV N2 times N4 over N3 times N5 صح؟ هيدا ال first set وهيدا ال second one. So we can, if we take them identical حيكون عندهم نفس ال gear ratio حيكون N2 over N3 equal to N4 over N5. اوكي يعني فينا ناخذ انه البينيون مثلا عنده نفس النمبر اوف تيس لاثنين والجير عنده نفس النمبر اوف تيس لاثنين. اوكي هلا بما انه هن بدهم اذا عندي جير ريشيو اذا بدكم larger than 1 يعني انا بدي زيد الانجلر فيلوسيتي ساعتها الدرايفر المفروض يكونوا الجيرز والدريفن المفروض الدرايفرز المفروض يكونوا الجيرز والدريفن المفروض يكونوا البينيون فانا اقدر زيد الانجلر فيلوسيتي. اذا العكس بنقلب القصه. اوكي so here I need omega out omega in to be equal to the product of 2 gear ratios. واذا بدي يكونوا identical sets يعني انا I assume identical sets تبلش اعمل ديزاين بس يمكن ما تزبط معي يكونوا identical ساعتها بشوف شو هي الكومبينيشن اللي بتزبط. So if I assume I want to use identical sets, the gear ratio for each of these مفروض يكون 100 radical of 180 لأنه أنا total MV هي the product of gear ratio of the first set times gear ratio of the second set. Okay, so for each set I should have a ratio of 13.416 which is larger than 10 so it's not acceptable. يعني بلش أقول إنه I cannot use just 2 sets. I should move to a larger number of sets. Now let us move to the to 3 sets. تنشوف إذا بتزبط. If we use 3 identical sets, each one should be characterized by a gear ratio of 5.646, which is less than 10. يعني this is acceptable. So I can work with 3 sets. Okay. Now can I use them identical or not? We should check. Okay, to check this مفروض هن بالبروبلم يكونوا عاطينا some constraints. يعني are we using, if they don't mention anything in the problem خدوا ال pressure angle 20 degrees. هلا if they give you, if they tell you you want to use 25 degrees pressure angles, for example, you can use 20. You use, and you go to your table and you look for the interference for the case of 25 degrees pressure angle. What is the minimum number of T's to avoid interference? إذا بنروح على التيبل ببين معنا إنه the minimum number of of T's for the pinion is 12 T's. فينا نبلش من 12 إذا بدكم، أو فينا to be on the safe side بناخد شوي values أعلى. You can start from 12, 13, or you can directly say let me be on the safe side كبر شوي. So here, for example, they started with 14. They tried 14 T's. They tried 15, 16. And why they are trying several possibilities؟ تيتأكدوا إنه مفروض ال number of T's للgear يكون منه ما يكون عنده decimal numbers. Okay, so we'll try to get integer values. If not possible, بدنا نقرب as much as possible to an integer. So if you observe these three, the closest one to an integer value is this one, which is 79.05. So I can say I cannot with these conditions. هلا فيني ضل جرب. Okay, او بما انه انا عندي فريدم بالديزاين ما عندي constraints كثير، فيني اقول انه 14 for the pinion is good، وبدل ما اخذ ما حفيني اخذهم identical. So let me move now to say I will consider my pinions split on 14 T's, بس I can play with the number of the gear ratio of my sets بطريقه يطلع لي the number of T's for my gears كلهم without decimal points. Okay, so what I will do then, I will say let me try to decompose ال 180 مثل ما عملنا هونيك بالexample. So because if I take them identical كلهم 79 for the gear 14 for the pinion, the total gear ratio بيطلع minus 179.68. أول شيء ليش negative؟ لأنه عندي 3 sets. مثل ما قلنا بالcompound gear trains إذا number of set is even بيطلع لي positive ratio، إذا it's odd بيطلع لي negative ratio. هون عندي 3 sets, so I expect opposite angular velocities. Now, with 3 identical sets, I was not able to reach exactly 180. This is why I should use different sets. Okay, and to select these sets بدي أعمل decomposition لل 180. يعني 180 can be written as 2 times 2 times 3 times 3 times 5. Okay, when I do this decomposition and I need to select 3 sets, مثل ما قلنا I try to have 3 sets of close ratios. يعني ما يكونوا كتير بعاد ال ratios طبعا. يعني مثلا عندي several possibilities هون. I select the one that will give me gear ratios that are close to each other for the 3 sets. So if you look here, if I combine 2 with 3 بيطلع لي 6. If I combine 2 with 3 بيطلع لي 6, so I have 5. يعني the best option in 3 sets هي 6 for one set a gear ratio of 6, for a second set a gear ratio of 6, and for a third set a gear ratio of 5. فينا نقي غير شيء بس ما حيكون كتير قراب مثل هون. يعني إذا باخد مثلا 2 مع 5 بيصير عندي 10، وهوليك مثلا بيصير 2 مع 3 6 و 3. This is not good. أول شيء بعاد عن بعض وعندي large value here. So the best combination for 3 sets حتكون 5 6 6. Okay. Now whenever I select the gear ratio for each set وأنا نقيت number of T's pinion 14، صار فيني أعرف إنه for my first set مثلا the number of T's for gear is 14 times 5, while for set 2 and 3 number of gears حيكون 14 times